So here's your first side of your maths memory revision card on box plots. So let's look at this key information over here. So the first thing we're going to get out of this video is to learn how to plot a box plot. Learn 5 different key statistics which you'll be able to identify and use them to plot any box plot. Number 2, we're going to compare 2 distributions, 2 data sets basically, 2 box plots, and you're going to learn how to comment on 2 different statistics on that. Thirdly, interpreting percentages from a box plot, i.e. how to identify and use 25%, 50% and 75% when dealing with the written answers. So obviously this is called box plots, this topic over here. It goes hand in hand with cumulative frequency. It's a grade 6 topic. Leave this example here to write your favorite questions, and hopefully we'll get 3 steps from this video for you to write at the end of this. So let's turn over to our toolkit. So on your toolkit, if you can write 3 different categories somewhere on your card, A, B, and C, and we're going to show you how to fill these in after you tackle a few of the questions in this lesson. Question 1, back to basics, box plot. Let's press pause. Let's write this question down. Try to attempt this the best you can. This is giving you the best introductory kind of method to understand and identify box plots. Press play when you have ready. So any box plot has 5 ingredients, 5 statistics. We say it's the low over here, it's the high, median, a lower quartile. And normally we have a statistic called the upper quartile, but in this case it's interquartile range. So this should not be upper quartile, okay, but we're going to make it a bit more complex to make sure we understand this and call it interquartile range. We could say there's 6 statistics. In fact, the interquartile range should be in the last one. But just understand there are going to be 5. So I'm going to write upper quartile over here, UQ, because that's what I really want to do, okay? Now all we do is plot these 5 statistics, okay? So the lower quartile will be, the lower mark would be 32. So 32 would be over here. I'm putting a line. It doesn't matter how long the line is, as long as it's a line, something like that. Next one will be the high. The highest mark in this class was 94. So 94 would be over here. Again, put a line there. Median mark 57. So 57 would be over here. Lower quartile 41. So roughly over here. Now it says interquartile range. You want to find out the upper quartile. So upper quartile, let's go for this. Now, if the interquartile range is defined as upper quartile, take away lower quartile. Let's just write that down, in fact, over here. So basically, if the lower quartile is 41, it must be 41, okay, plus 36, because that's going to give us the interquartile range if we work backwards. So if you do this, we get 7, 7, 77. So that's going to be upper quartile, 77. 77 is over here. Put a little mark over here. So now we create our box. Now our box is basically from the lower quartile to the upper quartile. So from 41 up to 77. That's going to be our box or interquartile range. Same word, box and interquartile range, by the way. And these are our different bits on the end. We used to call them whiskers, but now I think you call this box plot. So there's a box plot over here. Remember, we need 5 statistics. We need the low over here. We need the lower quartile over here. We need the median, upper quartile, and high. Those 5 things will give you the basic setup for this topic. Remember, the interquartile range is defined as the upper quartile. Take away the lower quartile. So if you wanted to put this as orange over here, the 6th type of statistic, it's the box or the interquartile range in the middle over here. Something else as well worth memorizing as we go along during this video. Lower quartile represents 25% or less of the data, median 50% or less of the data, and that's a 0 there, and this is 75% or less of the data. Obviously this is 0%, the low, and the high is 100%. Let's crack on with these core questions now, because you've got a quite a good start on your basics. So let's go back to our toolkit pod A on our revision card, and let's write this first, the key aspect that you've learned so far over here of how to plot a box plot with these key different 5 statistics: the low, the lower quartile, the median, upper quartile, and the high, and also the box representing the interquartile range, 50% of the data around the median. So write this down on your revision card on section A, and this will give you a good starting point for the rest of the lesson. Question 1, core 1, box plot. Let's press Pause. Let's get down these two box plots, compare the two distributions, and press play when you're ready on this exam style question. So the box plots show two identical 200-meter races run by identical boys and girls, two categories in year 9, and these are their respective seconds. So for boys, we simply show the box plot with the 5 statistics we just talked about, and the girls with their respective statistics as well. Now the question says compare both the sets of distributions on the time taken by the boys and the girls. So comparing is a technique we need to learn, and this comes up quite a lot, comparing two different sets of data or two box plots. So the first thing we need to know is what statistics do we actually compare. So the first thing we do is compare the median, okay? The median of the average for both of these sets of data. So let's take a green one to show for the median, green color. The median for the boys is 41 seconds and for the girls is 49. Now the lower the number doesn't mean the worse number that is, okay? Now the lower the number sometimes has to be linked to the actual applications. So for example, for this question involving athletes or students running the race, a lower seconds means it's a better result because they've taken quicker to do it. So let's take two categories. We'll take the boys over here and the girls. So the median for the boys was 41 and the girls was 49. So 41 is less than 49. So you need to write something about how 41 seconds is less than 49 in the race, and therefore that's why it's a better result. Okay, so always link it to the application. We won't write it. We'll leave you to do it in a subjective way. I'll just leave a little bit of dashed lines there for you to do that. Number 2, let's talk about the second statistic. It's called the interquartile range. Upper quartile take away the lower quartile. We talked about this meaning the same thing as a box. Okay, so maybe we'll call it orange over here. That's the same thing over here. Let's work at each one of these for each respective sets of the boys and girls, and then we'll compare them. Okay, get some keywords for you. So the boys, upper quartile, 48 to take away 31. That would be 17 over here, and for the girls, it would be 57 take away 36, a bit more, 21. So boys is less than the girls. Now, is that better or is it not? I mean, the lower the interquartile range, the more consistent the data is. Okay, so the boys are more consistent, and this is the key word you need to really write in the exam. It's consistent or predictable or lower spread, either one of those words. Yes, consistent, more predictable, or it has less of a spread. That means it's better, okay, because it's more aligned to the actual race. It's like more pupils are actually running the race within these intervals, rather than one being maybe super fit and running the race really fast and one lagging behind and taking, let's say, a long time. All right, so anyway, so this is what you really want in this question over here. Interquartile range, the lowest interquartile range means the more consistent. Write that down as well. That's where you get the marks. Median and interquartile range. So let's get out our revision card and let's look at toolkit B, and let's now write some notes on comparing two sets of distributions. So the main key elements are the median and the interquartile range. Make sure you understand how to write a sentence, obviously, or more on these in regard to the actual application of the question. So look at this, write this down, and obviously make sure you understand these two statistics over here. Question 2, core 2. Press pause, read this question, answer parts A and B, and press play when you are ready. So a class of 32 pupils completed a maths puzzle. The box plot below shows information about their completion times in minutes. So straight away you should be able to identify what these 5 statistics mean on a box plot. 16 the low, 18 the lower quartile, 24 the median, 28 the upper quartile, and 35 the high. Now this question particularly pays attention to the percentages of each of these stats over here. We'll call them stats to make it a bit easier for you. Okay, so let's see what they both each represent. Oops, that should be high. So lower quartile 25%, median 50%, and upper quartile 75%. And these should be respectively all these percentages or less, by the way. Now, what percentages of boys spent less than 24 minutes to complete the puzzle? So if you look at 24 over here, this represents the median, and everything below this over here is actually 50%, if you look at it like this. So, and everything above, obviously, from here to here would be 50% as well. But the question is asking is below, so the answer is 50%. It's just self-evident from the box plot. Let's look at the next question. So how many boys took more than 28 minutes to complete the puzzle? So slightly longer. So we know 28 is over here, and this represents the upper quartile. Anything below that is simply going to be 75%. If we can just write it over here. Everything below here is 75% because 75% of students achieved 28 minutes or less. So therefore, if 75% is less than this, what has to be above this? From the upper quartile to the high, it's got to be 25%. So that's what the question is asking, because it's more, which is the more bit between the high and the upper quartile. So the answer is simply 25%. These questions can be simply be read from the box plot itself, looking at the respective statistics as such. So let's get our revision card out and let's look at section C here on our toolkit, and let's make the heading interpreting percentages. So obviously we've found out from various questions that the different statistics on the box plot mean different things. So the lower quartile means 25% or less, the median 50% or less, and the upper quartile 75% or less. These questions come up a lot when interpreting or analyzing the box plot. Also take note of a question that could say or more, which means obviously 100% take away these. Okay, so it could mean or less or more. Okay, we haven't done or more in this toolkit over here, but again, appreciate that too. Question 3 challenge box plots. Let's press pause, write parts A, B and C down on a piece of paper. Grade 6, this is 4 marks. Press play when you have done this. So this is slightly different, this question, because we have a list of data, okay? A list of discrete data, numbers. And how do we find your 5 statistics, your lower quartile, median, upper quartile, and your high from this? That's the question. How do we number crunch this? So first of all, let's put this in order. Now let's read the question. Ruby planted 11 tomato seeds. After a period of time, the plants grew to the following heights. Okay, so here we have a bunch of 11 numbers. It's odd. It could be even as well. It doesn't make a difference. Let's put them in order first. So we're going to write them over here. So we have 12, 17, 19, 20, 25, 26, 27, 32, 35, 38, 42. It's always good to cross them off as we go along. But anyway, let's find out what these 5 statistics are. So first of all, the low. Low is very easy. The low, L for low, will be 12. Okay, you can see it over here, the first number. Second statistic, lower quartile. So this will be n plus 1 over 4. It's always n plus 1 when you have a list of data, i.e. the data is discrete. If you want to be continuous in the frequency table, it's n over 4, by the way. Okay, it's not the plus 1. You always plus 1 when it's a list of data. So this will be basically 11 plus 1, which is 12. 12 divided by 4, which is going to be the third value. Okay, so the third value would be, let's have a look and see. Let's make this yellow. Third value, 12, 17, 19. This is the lower quartile over here. So 19. Don't write third. You just have to write 19, where we've highlighted this in red. Let's move on to the next one. So the next statistic is going to be the median. Let's put a little line over here. So the median will be n plus 1 divided by 2. Okay, so n plus 1 over 2. So this is 11 plus 1 divided by 2 is the 6th value. Okay, so the 6th value over here. And this would be, let's put this a different color, green maybe. 1, 2, 3, 4, 5, 6, 26. So that would be your median value. All right, so we'll put 26. And again, make it red, so make sure that's the final answer. 26 centimeters, in fact. All of these should be centimeters. Yeah. All right, the fourth one is the upper quartile. So the upper quartile is 3 times the lower quartile. So 3 lots of whatever we saw for the lower quartile. So this is the 9th value over here. Okay, the 9th value. The 9th value would be, let's count this up again, a different color. Let's make this maybe orangey over here. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 35. So 35 would be your upper quartile for this. And your high is quite easy to do. Your high will just be the simplest one over here. High would be 42 because that's your highest value on your tomato seed. So you've number crunched this quite well now. Your statistics, let's just plug them into our box plot. The easy bit to represent this on here. So your low is 12, 12 over here. Your lower quartile 19. Your median 26. Just about to see this one over here, 26. All right, 35, your next one over here, and 42 over here. Okay, let's join up the lower quartile to the upper quartile to get our interquartile range. And let's get our little whiskers, we used to call them, but now it's just called a box plot, the whole thing. All right, so these are your 5 statistics. Let's write them: low, lower quartile, median, upper quartile, high. Once you've got that, we know to the question. So part B, what percentage of plants grew 35 centimeters or more? So again, let's look at this, all the 5 statistics. Now 35 centimeters represents upper quartile, which is going to be 75% of the data. Okay, because 75% of the plants had a height of 35 centimeters or less. That's what it means. So if you want 35 centimeters or more, it must be 100 take away 75. Okay, let's do a little arrow to make sure you understand what we mean over here. Everything over here is going to be 75%, okay, because that's what the statistic means for upper quartile. So if that's the first thing we look at, 100 take away 75 is 25%. The answer is going to be obviously 25%. Okay, what percentage, this is part C, of plants grew between 19 and 42 centimeters? So 19 centimeters is lower quartile, 25%, and 42 is the high, 100%. So 100% take away 25% would be 75%. Okay, so that's again everything from the lower quartile upwards. That's how you'd answer that question over there. So this is how your summarized toolkit should look like with sections A, B, and C respectively. So just review this, have a look at this, because we're going to use this now for the Let's Do It questions. So use these cards to tackle the exam style questions. Question 1, let's do it. So let's now take the chance for you to apply your revision cards to see what you've learned and put this in action for the following 2 questions. So press pause, write this question down, and press play when you have finished. Question 2, let's do it. So press pause, read this question, write down your answers to parts A, B, and C, and press play when you are ready. So this question is dealing with a list of data, and obviously when we have this, we have to see how we can find these 5 statistics: the low, lower quartile, median, upper quartile, and the high. So the first thing we need to do is to write this in order, because the question is asking us to put these list of numbers from a GCSE exam and put them in order to find the interquartile range. So this is what we did before. So 17, 25, 31, and this is the list over here. So let's find the interquartile range from here. So you know from a previous question we did something like this. The interquartile range is defined. IQR, to call it brief, is the upper quartile, take away the lower quartile. So let's define the lower quartile over here. Okay, so the lower quartile is simply going to be n plus 1 over 4, and the whole thing we want to find out from our list above here. So n is 15 if you count this list up. 15 plus 1 is 16. 16 divided by 4 is the 4th value. Okay, so it's very important to put the 4th value, the word value here, not the 4th number. A lot of students just put number 4. Okay, so it doesn't make sense. So the 4th value, let's count up from the beginning over here. So the 4th value, let's go up. So we got in our list of data 17, 25, 31, 36. This would be our lower quartile, the 4th value over here. Let's just write that down, LQ. So similarly, let's find our upper quartile. We need to find that out, obviously, to get this whole thing understood properly. So the upper quartile is very similar to the lower quartile, but it's obviously 3 times that. So n plus 1 over 4. Let's see this value. So this would be n. N is 15. 15 plus 1 is 16. 16 divided by 4 is 4th. And 3 divided times 4, sorry, is 12. The 12th value. you could obviously just get it by timesing the lower quartile by 3. That's what I do actually sometimes. So 12th value, if you look at this, I'll just go backwards in this case over here because it's quite difficult to start from the beginning sometimes. 15th value, 14th, 13th, 12th. There we go. 63. This is the upper quartile over here. So let's take away both of these from each other. So if we do that, upper quartile take away lower quartile, 63 take away 36. This would give us a value of 27, and that would be your final answer for part A. So part B, what percentage of pupils scored 36 marks or less? So this is where we have to understand how this list of numbers works. So 36 or less. So 36 represents the lower quartile, and this number will normally be on par with one of the main statistics on this list of data. It happens to be the lower quartile in this case. So this quartile means 25% or less of data is 36 or less. So 25% of pupils basically scored 36 or less in this exam. The answer is 25%. Look how we looked at this word or less, which makes sense in this case, okay? Part C, what percentage of pupils scored 63 marks or above? So again, this represents 63 above here. Now, it says above over here, which means it's going to be above this. So we know that 75% of people scored 63 marks or less in the exam. So obviously, common sense tells us 100 take away 75 is 25. 25% would have had to have scored anything above here. This represents 25%, this little arrow over here. So that's going to be 25%. The question's nicely linking it to this list of data over here. So congratulations, you now have finished box plots, this silver topic lesson. And make sure you've understood all the different key areas within this topic by reviewing and going back to them. And rate yourself on your feel-good factor on your revision planner out of 10. How good do you feel in this topic over here, box plots? So give yourself a tick on your let's do it circle on that, and let's move to the next topic.